Hi everyone. My name is Sue, and I will be your moderator for today's session. And thank you so much for being here. And now let's get started by introducing our speaker, Kutluhan Aktar. He's
Hi.
a self-taught developer and Agentpost ambassador, a maker, and an independent researcher. So today, Kutluhan will be sharing his projects with the topic of creating individual solutions for industrial-grade environmental problems with tinyML. Before we dive in, I want to give a big shout out to all the amazing partners who are taking tinyML to the next level with us. They are AIZip, Analog Devices, Arduino, ARM, Brainchip, Agentpost, Brainwaves, Groovy Inc., IBM, ImageMob, Infineon, Inotera, Microsoft, Nota AI, NXP, Pollen Technology, Pixel, Qualcomm, Renesas, Schneider Electric, SensiML, Sony, Silicon Labs, Life Augmented, Synaptics, and Sentient. Thank you very much. And if this is your first time here, a warm welcome to you. We've got an incredible tinyML community that's growing like crazy. We've got 15.5 thousand members across 49 countries in 41 countries on Meetup, and we've got 4,000 members and a 12.4 thousand followers on our tinyML linking community. So please feel free to join us by scanning the QR code and come on, be part of this community. And we also have a YouTube channel with over 9.8 thousand subscribers and more than 500 awesome videos with over 300,000 views. If you want to catch up the previous talks or stay in the loop with the latest tinyML news, just scan the QR code and subscribe. So now let's welcome our speaker today, Kutluhan Aktar. He's a self-taught developer and maker who enjoys contemplating proof-of-concept AIoT projects in various fields. He was an aspiring physics major, but decided to drop out of university in order to follow his vocation to be an independent researcher and build original projects from scratch. With the help of lots of innovative companies, he has been able to keep devising inspiring projects and realize his ideas in recent years as an occupation. Welcome.
Thank you so much for having me here. I will start my presentation now. In this presentation, I will talk about creating individualized solutions for industrial-grade, environmental, and health-related problems with tinyML and my approach, my perspective to how we can utilize tinyML hardware and products to create more affordable and comprehensive solutions. First of all, I will talk about the challenges with machine learning and large-scale problems. As an example, I will talk about the pest detection system, to creating a pest detection system, for example, for 100 farms in different continents. So if we try to do that with machine learning, we will have these problems. First of all, the most challenging problem will be defining all possible use case scenarios, because all farms in this different 100 farms will be different needs and different soil types, different animals living in there, and since they are in different continents, there will be lots of different weather conditions and different use case scenarios. Then second, grasping the extent of the targeted problem. When you target a big problem with machine learning, sometimes even before working on solving the problem, you need to create you need to grasp the extent of the problem and make lots of research even before devising the solution for that problem. Then interminable workloads due to the lack of talent. Although there are lots of people working on in the machine learning and artificial intelligence areas right now, still there are many few people than required in this field to solve all of the problems by creating large-scale solutions for large-scale problems. Then exorbitant cost due to the hardware requirements. When you create a solution for a large-scale problems, the required hardware and required memory, storage, and computing power sometimes requires 10,000, more than 10,000 computers to even calculate the initial algorithm, even before creating the solution. Also, the most important thing is creating a dataset to solve a problem with machine learning, and constructing a miscellaneous dataset required to solve a large-scale problems, as I talked about for 100 farms. If you try to do that 100 farms, create a solution for that, we need to create terabytes of data even before starting to work on this solution. Then inaccessible and inaccurate data will be our next problem, because when you divide your force to solve a problem with these different farms and different units of data set points, you need more people, more manpower to collect this data and create not maybe one, but more than 10, 12 maybe data sets, and combine them together to create a meaningful solution. Then adapting to sporadic conditions, irregular conditions, because when you focus on a large scale problem, even for a one farm, there will be lots of unexpected and unprecedented conditions before you try to understand the problem, and it will create maybe more workload and more power to your team. Then building complex algorithms. When you focus on solving a problem with machine learning, maybe the provided algorithms and solutions will not work for you, and you need to create an algorithm from scratch, even before generating any profit from your idea or your work occupation. Of course, then cloud computing and storage space. As I talked about earlier, when you create miscellaneous dataset, you need lots of storage space and maybe pay some cloud computing services to create your solution, to build your solution. Then it leads to our following problem: meager funds and limited market opportunity. Maybe your idea will be innovative and create benefit for lots of small businesses and farms and different people and brands, but if you cannot find adequate funds to keep working on your solution, you will stuck in this some step of your work. Then how we can solve these problems by utilizing tinyML and affordable hardware. In this slide, I will talk about the advantages of creating an individualized solutions for large-scale problems, but by dividing the problem with smaller units. Instead of focusing on 100 farms to create a pest detection system in 3 different continents, you can educate people, farmers or local firms, to create localized solutions and individualized solutions for each farm instead of focusing every farm. Then focusing on then when you do that, you will focus on a just single use case scenario of a large scale problem, not every 100 different possible environment to collect data. Just one farm or one data point. Of course, when you do that, you pinpoint and refine the solution method because you only just focus on one problem, one area, instead of focusing on 10, 100 or 200 different data points. Therefore, you will have manageable objectives instead of solving lots of different problems. You will just focus on one farm. In my example, I will talk about farms, but you can apply this on different solutions. For example, if you work on solving or detecting diabetes before it creates a bigger health solution, instead of focusing 1,000 people, you will only you can create an individualized solution for one people, just collecting data from that person and creating a unique data set. Also, when you do that, it will create considerably low budgets and affordable hardware because you do not need to use a computing service or a cloud service. You can even do that with on a Raspberry Pi or Arduino. You do not need to squander your budgets on different hardware. And you will have a constricted data set, as I said, instead of collecting miscellaneous data from different data points, you will only have to work on one environment to collect data, one data point. Also, you will have efficient data collection because even though in time, your collection point, your data point will change in time, you can easily adapt to that changes instead of focusing on more than one data point. Also, by doing that, you will create a consistent and stable instances. You do not need to adapt irregular or sporadic conditions by focusing on one data point. Then you will able to use optimized algorithms for simple tests. You do not need to create your own algorithms or build a team to create a more convoluted solution. You can just utilize the assets given to you. Of course, when you do that, if you do not need more storage space or you don't need more than one computer to calculate your solutions, your results, you will have minimum latency and power consumption. Also, you will minimize your footprint by doing that also. And no need for profit from continuing operations. You do not need to create this as a service. If, in my example, every 100 farms will learn how to utilize tinyML and this affordable hardware on their farms and detect pests by utilizing their own solutions, they do not need to pay or create a continuing operation and support their business by getting or providing a profit from that. How we can create and educate people, teach them to utilize tinyML on their businesses, on their small businesses to improve their revenue and profit, but not creating a profit focusing on machine learning, but their own jobs, their own ideals. We have assets for tailoring solutions with tinyML for specific problems. First of all, most importantly, specialized development boards for Edge AI. Lots of firms, especially Seed Studio and Arduino, Raspberry Pi, they provide these Edge AI devices just focusing on solving the problem, but not forcing the user to spend lots of money on the hardware. Also, we have lots of different transmission methods, Wi-Fi, Bluetooth, LoRaWAN enabled edge devices, just focusing on the transmission method and can run the models easily, created models easily. The model can be created by TensorFlow Lite or Edge Impulse or or you can even code your own model utilizing SDKs. Then pre-configured sensor and cameras with supported libraries. Especially in the last 3 years, brands like you created lots of different sensors and devices to collect data from in the environment, local environments. and specified AI cameras to capture images on device, collect data on device, and then train the model on device, even without utilizing a transmission method to transfer your collected information to a computer. Just on device, you can train your model on device. Of course, single board computers like Raspberry Pi, Latte Panda, or terminal provided by Citizen, you can utilize these single board computers to run more complex model or multi-models if your problem requires to run more than once models. Also, AI platforms, as I myself from an AgImpulse ambassador and working with models created with AgImpulse, they will make your job very easy because you do not need to learn how algorithm works or how you can create an algorithm from scratch for a problem, because they already given the most suitable algorithms and models for your problem, and this model will be constricted and can work on lots of different devices and deployable on lots of different devices. So you do not need to worry about if I can work on these Arduino devices and cannot work on devices provided by Citizen. They will provide you all the solutions and deployment methods, all of your devices especially. Then cloud computing services like Amazon's cloud services or Google Cloud services, even though you do not need to utilize a cloud computing service, you can use these services to save your data, to create your data set and save them on cloud computing services to utilize the same data set on different devices. Then optimize algorithm, as I talked about earlier, if you focus on only one problem, only one aspect of a large scale problem, you will have optimized algorithms and model structures for your problem, because you do not need to think outside of the box to create a new solution, a new understanding of the data, because your problem will be require a considerably small data set, and optimized algorithms and provided algorithms by these AI platforms will suffice your needs. HTTP and REST APIs, I utilize them mostly to inform the user of the model detection results and not actually collect data, because provided REST APIs and HTTP APIs will give you lots of different opportunities to take the data with one transmission method and transfer it with another transmission method. Or, for example, if you collect data with Bluetooth transmission, then you can transfer this data utilizing through a single board computer by utilizing a REST API and provide Twilio's APIs and send a WhatsApp message, or utilize AWS Amazon services APIs to create a notification for your Android or Apple applications. Then, of course, SDKs and development tools. This will give you the opportunity to create and train your model on the device instead of collecting data and train your model, then deploy your model on the device again. First, for example, AgImpulse's SDKs will give you the opportunity to directly collect data on the device, train the model, deploy the model without even bring your data out of your device. Of course, as I talk about that, to educate people about tinyML, our biggest and most important resource are open source projects and tutorials like on GitHub, Hackster.io, Hackett.io. These projects will give you the insight of how you can utilize these algorithms. Even though you do not need any experience in data science, you can create your individualized solutions for your small business or farm or health-related solutions easily by following the previous tutorials. Then I will talk about my approach to creating individualized solution for large-scale problems. As mentioned earlier, I like to call myself as an independent researcher because I like to focus on a large-scale problems and think it as just focusing on one aspect of it and create a solution for my targeted problem. Even though it's a large-scale problem, I will degrade it to a more easy to solve issue. First of all, when I encounter a large-scale problem, when I read about it or think about it, I first of all peruse research papers to fathom the targeted to better understand the problem. It can be industrial grade, environmental or health related problem. I try to learn more about it and how people created solutions about that problem earlier than me. If tinyML applications is required for that problem, or I can solve it by utilizing if-else conditions. Then when I understand the problem more, I choose the most suitable transmission method for that problem. If you work on a farm, especially, you do not only think about transferring the data with Wi-Fi because it cannot be reachable or accessible on that area. Then devising a budget-friendly and accessible device capable of collecting data and running inferences. I always like to collect my data set to fortify my point of view about tinyML instead of utilizing the pre-configured data sets. I always create my own data sets and then I create my model. Then I find about the collecting my data, I find a local array depending on the large scale problems, my targeted problem. I find a local array providing my data set. If there is no local array that I can collect my data, I design a controlled environment for data collection. Then I collect my data before training my model. After collecting my distinctive data set with notable validity, I build and train my neural network models, object detection models with Edge Impulse. As I said earlier, I am an ambassador at Edge Impulse, and I really like utilizing their software to create algorithms. It's very easy, and you can create your models probably in just 1 hour. After creating my model, I do not stop there and conduct further experiments and to try to polish my model's results and how it can generate results in the real environment in the field before applying and preparing my tutorial for that device. Then maybe my most important approach to create these solutions, these devices, developing an application interface to inform the user of the model detection results, because it is not suitable just only generate results, but do not create a supporting way to inform the user of that results. Then I will talk about my 4 different projects showing my approach to large-scale problems. My first project I will talk about today is AIoT AI-driven 3D disease identifier with Edge Impulse. In every project I first of all create a bullet point list for the issue and the solution. In this project, the issue was due to the climate change and excessive deforestation, trees and plants are becoming more susceptible to contagious diseases, and most tree diseases are fungal and instigated mainly by drought, high carbon dioxide level, overcrowding, damage to stem and roots. And since trees and plants are crucial for pollination, spreading tree diseases can cause crop yield loss, animal deaths, widespread infectious epidemic, and even land degradation, soil erosion. Various environmental factors can cause trees to be stressed and catch a highly contagious disease. Tree diseases can engender unrecoverable damage to forests, farms, and arable lands. Even though I talk about this mainly affecting human life, it's very dangerous especially dangerous for the wildlife, even more than humans. Then I devised a solution for these issues, what we can do to improve this condition and solve this problem. First, detect tree diseases diseases before permeating forests to avoid their detrimental effects. Then provide prescient warnings regarding potential tree diseases and environmental factors. Not that just detecting tree diseases will solve these problems, because if we cannot pinpoint the starting point, we cannot devise the required precautions to solve this problem. So also giving the user the current environmental factors when this disease is detected, very important to solve this problem. Then collect data from trees infected with different diseases in order to train an object detection model. In this project, I choose to utilize MMS to notify the user after running the object detection model, because it is more suitable for the array I collected this data, but you can apply different transmissions method for informing the user instead of MMS. And then I also design a 3D printable case and share the files online as an open source project, because I think it is nearly as important as creating a solution, but also protecting it. If you do not create a prototype for this proof of concept projects, you cannot achieve to improve these projects as a more worldwide solution. Then in this project, collecting environmental factors. First of all, I try to collect environmental factors with bioterminal. I utilize grow sensors, grow carbon dioxide, temperature, and humidity sensor, and SenseCap K1100 kit to create this project. This kit includes bioterminal and the temperature sensor I required, also the grow AI sensor I required. So I utilized to collect. First of all, I configured bioterminal on Arduino IDE and assembled the forest themed case. I try to in my every project I try to design a theme, find a theme to suitable for my solution. So in this project, I decided to create a forest inspired case. Then programmed bioterminal to save the collected environmental factors to a CSV file on the SD card. Since bioterminal provides an SD card slot, mini SD card slot, you can directly save the collected data on the SD card without transferring your data set. So I collected carbon dioxide, temperature, humidity, moisture, total volatile organic compounds, carbon dioxide equivalent variables, and save them by adding the current date and time in the CSV file. After that, I also utilize bioterminal screen, built-in integrated screen, to display the collected data as a histogram to notify the users near this device. Then I employed bioterminal to send the collection and model running commands to the Latte-Panda 3 Delta. Latte-Panda 3 Delta is running the model and bioterminal is collecting the data, and they communicating with each other via serial communication in this device. Then after providing this data set for my project, I need to create my model by capturing images of the infected trees. First of all, I updated the Vision AI model, Grow Vision AI model firmware to capture images in Python. I highly recommend Seed Studio's Grow Vision AI model if you try to create an individualized solution for a problem, because since it is a specialized Edge AI device, you do not need to do much to utilize this device. Just following the provided tutorial and updating its firmware, you can directly use Python to save images on your computer. In this case, I utilize the Latte-Panda 3 Delta single board computer to save my images, captured images. And I recommend, by the way, running Ubuntu or Linux systems to collect data with Grow Vision AI sensor, because when I try to utilize it in Windows, it throws lots of different errors due to the serial communication USB transmissions method. Also, I utilized the latte panda 3 delta to show a real-time video stream generated by the Vision AI module on the screen, but you do not need to, especially I did not need to see the images while collecting data because I collected my data outside. As I talked about earlier, I always try to create my data sets for my projects. And in this case, I find a local area near my hometown when there was a forest fire in there. Lots of trees catch different diseases, and I collected different foliar and bark tree diseases in a forest near my hometown. And some of these diseases I listed here: leaf grass, leaf spots, leaf blisters, powder mildew, needle rusts, needle casts, star spots, etc. After obtaining my data sets, collecting data 2 weeks in that forest, I started to train my object detection model with edge impulse. I utilized the FOMO algorithm to create my model because it's a constricted model and suitable for running on embedded devices. In that case, I ran it on Ratapanda 3 Delta, but you can even run it with the deployment models on Arduino Nano BlazeSense. After uploading my images samples, I labeled targeted objects on these samples. Also, it is the maybe most arduous things to utilize and create your own data sets because you need to label each samples for object detection models. And if you do not use a tool that assists you while you label your samples, it can be a very stressful and hard assignment. But thanks to Edge Impulse, when you label your samples, it tracks them, and when you switch to the next sample, you can easily follow the previous boxes and label your samples under maybe 50 minutes. Then I trained my FOMO model on the contagious tree disease, but as you can see in the previous slide, there are lots of different tree diseases I was able to collect information, but it is not suitable to train my model to detect every infection individually because it will sway me from my object in this project. So I categorize these diseases under two main classes: leaf rust blister and stem bark branch mildew. Then I trained my model on these three classes instead of training on 10, 11 different classes. Then I evaluated my model accuracy and deployed the trained model as a Linux application to run it on Ratapanda 3 Delta. But you can deploy the model and run it on nearly any provided embedded device. Then I set up the model on Ratapanda 3 Delta and conducted different experiments and different use case scenarios to polish my model's results. After that, I started to work on informing the user of the model detection results. Then I employed the Ratapanda 3 Delta to run inferences, modify the captured image by adding bounding boxes. The device is not only capturing images while creating the dataset, it also captures an image to run an inference to detect the object. So you can take advantage of that. And since Edge Impulse already adds the bounding boxes on the sample before running the inference, you can directly extract those detection image and send it to the user. Then I sent the image with an HTTP post request to my application. Then created a Tivoli account to send MMS. Developed a web application in PHP. I send this web application via HTTP post request. The web application takes the say transferred image and saves it under latte panda 3 delta and its local server. After getting the image and getting the detected class and the environmental factor information also with it, the device sends this information to the verified form number via an MMS, also adds the images linked on the local server. If you, as an improvement for this project, if you not want to use a local server, but create an interactive server to send this information not only in the devices on your local Wi-Fi network, but to wherever you want in the world, you can utilize a cloud service like ngrok or Amazon's cloud services to create this device more accessible. Then, by creating this proof of concept project and applying these models on captured infected tree diseases in detecting potential tree diseases, what we can achieve too? We can avoid crop yield loss, animal deaths, widespread infections, epidemics, prevent land degradation with soil erosion, mitigate deforestation, and protect wildlife. Instead of creating a big firm or brand to generate profit and to focus on these large-scale problems, we focused only a simple aspect, one data point of this problem. So if you think about it, if on around different countries, more than 10 or 12 people educate themselves and create this proof of concept projects, it can be more effective than a corporation or a firm to focusing on this problem. So individualized solutions can easily change and revolutionize our world and create a more sustainable future for us. I added the project tutorial in this link, so you can click and download all the files and model 3D printed files to replicate this project if you want to. Then my second project. In the second project, I will talk about IoT, AI-driven yogurt processing, and texture prediction. I came up with this project by researching a problem I heard while watching news, and some small businesses, some small dairies in my country losing their marketplace due to the new regulations, not adapting very well to those new regulations. So I tried to create a simple solution for that problem. What is the issue in this project? As you know, yogurt is produced by bacterial fermentation of different milks, cow, goat, sheep, etc. Even though yogurt production and manufacturing look like a simple task, you can do it in your home basically, but achieving precise yogurt texture and consistency with producing high quality products can be straining since various factors affect the fermentation process if you try to achieve a consistent product value. Most companies employ food chemically engineered additives while mass producing yogurt to maintain its freshness, taste, and texture. Mostly they use artificial flavorings, rehashed starch, sugar, and gelatin. Also different chemical additives, but due to the surge in food awareness and health regulations, companies were coerced into changing their yogurt production methods for the best, of course, for supporting our health. But these methods, without adding any additives, can be expensive and demanding for very small businesses trying to gain a foothold in the dairy industry. So what we can try to create to solve this problem? First, we can detect yogurt consistency levels even before fermentation by utilizing the environmental measurements. Then assist dairies in reducing the total cost and help them improve their product quality. What to do to achieve that? Collect data while producing yogurt in different conditions to train a neural model notable validity. Also inform the user of the detection results after running the model. Then, as explained in my previous project, design a 3D printable case while operating in a dairy for this device. First, collecting yogurt processing data with Shio ESP32C3. I utilize this Shio ESP32 in this project because it is a very small thumb size development board and provides you to run and collect data, also transfer this data with Wi-Fi, even its small size. So it is very effort for for a project like this. First, I configured Shio ESP32 on Arduino IDE to program it, then assembled the dairy themed case. I choose to create and design a dairy themed case for this project. Then programmed Shio ESP32 to save the collected information and environmental factors to a CSV file on the SD card. I was able to utilize the SD card easily because I integrated Shio expansion board. I integrated Shio ESP32 to its expansion board, and it provides screen and grow sensor connections, integrated button. So I was able to create my project easily with its expansion board. Then I utilized the built-in button on the Shio expansion board in two different modes, since it is restricting for me to collect and run the model by utilizing the same button. I utilized the long press and short press options to select a class and save data records. If you have a device like this and you need to work on a limited control button options or control units in a project, you can utilize even one single button to transfer and give different commands. It exactly counts the press time and according to that creates a command for the pressing time. Then also I displayed the processing data and selected class number on the device. And when you save the data, device also notifies you data successfully saved to the SD card under the CSV file. When I talk about the environmental factors for yogurt processing, I meant temperature, humidity, pressure, milk temperature, and starter weight, culture weight, yogurt culture weight. I utilize a gravity weight sensor to collect the starter weight data, and I utilize a waterproof temperature sensor to get the milk temperature. Then I constructed my data set. After collecting data, yogurt processing data from 30 different batches, as you can see, I showed 4 different batches, but I collected from 30 different batches. I created my classes thinner, optimal, and curd link for the model training. I always use the cow milk, but change always the temperature and different variables. Then I obtained my dataset on the SD card, including labels for each data record. Again, I built my neural network model with edge impulse. I already talked about edge impulse's beneficial advantages for your projects. After training my model, I set up the deployed model on Shio ESP32 as an Arduino library. And I divided my CSV file, my main CSV file, under different data records to easily upload my samples. I just developed a basic Python script and save each data record with their classes. As example, thinner sample 1, optimum sample 2, curdling sample 2. Since edge impulse can divide and extract the given samples class and label from the file name, I decided to choose this method to upload my data to the edge impulse. After running my model successfully, and I decided to utilize a billing application, create a billing application and a user interface, billing user interface to show the collected data and run the model. Since Xiaomi ESP32 can easily transfer data via Wi-Fi. I did not encounter any issues while uploading collected data items to the Blink application and show them on the screen. I also, since Blink lets the user to create a two-way communication with the connected device, I also utilize the same Blink application to give Xiaomi the command to run the model. So when user open the Blink application, user do not need to directly interact with the device. They can easily control the device by clicking the switch widget or button widget on the Blink dashboard and run the model, display the solution, display the collected data in real time, and even not need to go near to the device. Again, on this device, what we can achieve to make this device widespread and what we can achieve to improve for small dairies to improve their businesses. I also added the project tutorial here, so you can find this tutorial and again download the 3D file and create your own device as I shown here. And my third project is pipeline diagnostics and inspection with MMA. Pipeline system maintenance is crucial to keeping machine operations sustainable, profitable, and stable. Even though we control units evolved from occupying rooms to fitting our packets, we still need to transport liquids or gases to manufacture different products. And a faulty pipeline system can engender various manufacturing problems while running machine operations, and small businesses with limited budgets, not enough to cover expensive overhauling costs, may encounter different problems and maybe stop their workflows and cannot continue their production lines. Then during machine operations, mechanical and thermal stress cause minute defects in pipelines due to fatigue or stress. When small defects accumulate, the accumulation of this minute stress results in varying turbulence pressure, which leads to slight form disfigurations on the pipeline and gradually create a tension and create little cracks or disfigurations on the pipes. Although there are different external pipeline inspection methods, they cannot be applied interchangeably to different pipeline systems without halting or hindering the production line. Then to solve this issue, I think about establishing an efficient and accurate pipeline diagnostics mechanism conforming to general maintenance regulations, and in that way assist technicians in keeping machines durable and prevent companies from spending their resources on replacing machine components due to pipeline defects. Since pipeline system failures can be detected by inspecting fluctuating vibrations as a non-destructive method, this method can recently shown in groundbreaking research and detect the pipeline defects in sewers even without penetrating the ground or digging the ground, just on the surface on the road by utilizing the strong groundbreaking radars. Then I decided to inform the user detection results even though I utilized the MMA radar to create my dataset, I also decided to collect the image information and inform the user of the deformed pipes. And considering harsh operating conditions, I decided to design a unique PCB and a 3D printable case to make the device as sturdy and compact as possible. Of course, as you can see, I designed a Dragonite PCB and it will not be suitable for most of the firms, brands to try to utilize the same solution, but I wanted to show in my projects what we can achieve these different designing methods, PCB, 3D printing. So I try to pass the limit of what we can achieve these designing methods. So of course, you do not need to utilize the same PCB design, but you can find my design files, Gerber files in the tutorial. Then I needed to create data parameters, a data set, and collect data parameters to create my data set. To run my model and design my device, I decided to use the Arduino Nvidia Vision as the main component of the project, but unfortunately it works on 3.3 volts operating voltage. The MMA sensor sits yours MMA sensor, 60 GHz MMA sensor cannot be connected directly to it. So I decided to utilize an Arduino Nano, collect the data and transfer this collected data to the NVIDIA Vision via serial communication. After soldering the PCB and adding the components on it, I assembled the liquid team case, then developed a full-fledged web application in PHP to provide an outstanding user interface. As I mentioned earlier, I like to provide the solution to inform the user. So in this project, I decided a web application instead of utilizing a third-party API or service. Then I hosted the web application on Native Delta. Since I am not able to collect these issues on a real pipeline system, I built a basic pipeline system by utilizing plastic fittings and pipes. And each line has a different pipeline defects. As you can see here, blue section is cracked, red section is clogged with a bead, and green section leaking the passing liquid or air. After doing that, I programmed Arduino to extract data parameters from a CTO 60 GHz MMA radar module. You can utilize different MMA radar modules. CTO provides, I think, 5 different models for MMA data extraction. So you can select one of them, but I decided to use the 60 GHz one. Then transmit the collected data to NVIDIA Vision via serial communication. I utilize the control buttons I connected to Arduino Nano to select a class. I always try to add control buttons or units to my projects, select class. Then it is more suitable than adding class after collecting the data while collecting the data. Then I employed NVIDIA Vision to transfer the received MMA data parameters and selected classes to the web application I created via HTTP GET requests. Then I used the web application to store the collected data in a MySQL database table. As you can see, I displayed all the collected information with dates, collection dates, and extracted MMA parameters and the given labels on the second HTML table. And I give the user the option to create a CSV file by these saved data records. Also, the device displays the selected class and the collected MMA data on its screen. After that, I built my neural network model with Edge Impulse trained on the extracted MMA data parameters. I easily uploaded my generated CSV file to Edge Impulse and extract all data records as samples utilizing the CSV wizard. As of 2 months or 3 months now, you can directly upload your CSV files to Edge Impulse, even if they are not time series data. You can generate your template for your CSV file, and every CSV file you upload after that, Edge Impulse automatically can extract and build your samples instead of you uploading samples individually to Edge Impulse. You can now do it in a single CSV file by selecting a data field as your labels. I utilize as labels clogged, cracked, and leakage, and as my pipeline system, I will demonstrating manifesting these 3 problems. After training my model, I evaluated its accuracy and deployed the model as an Arduino library and set up the deployed model on NICLA Vision. After perfecting my model's results and data solutions, I decided to utilize again my web application I built from scratch. The web application gets the data and model detection results from NICLA Vision, but this time via an HTTP post request instead of a GET request, and save the picture, deformed pie picture captured by NICLA Vision to the server and show the user the detected class, the deformed pipe images, and the which data items the model utilized to predict these results. Also, it's web application, since NICLA Vision cannot generate a JPEG file in a image format, it only able to create a raw image buffer. Application also turns the created buffer, transferred buffer, into a JPEG file, formatted JPEG file. Then user can utilize this interface to solve all the model detection results and the converted images on this device. On the web application, the device runs the model every 60 minutes, but the user can adjust depending on their requirements. Then what we can achieve to apply these models: we can keep machine operations sustainable, profitable, and stable, prevent fault pipeline system from engendering expensive manufacturing problems, assist small businesses and factories with limited budgets in establishing an efficient, accurate pipeline diagnostics mechanism, reduce repair costs and of high-value machine components, and provide a non-destructive testing and evaluation mechanism based on vibration. Again, I added the project tutorial here, so you can download all the model files and STL files about this project. Then my latest project is the IoT AI-derived Laravel fertilizer pollution detector with WhatsApp. In this project, I decided to use two different transmission methods and combining them to inform the user more efficiently. I will explain it in the following slides. In this project, the issue is due to the ever-growing human population and declining fertile lands. Farmers needed to utilize organic fertilizer in conjunction with chemical fertilizers to improve crop yield, even to the extent of causing soil contamination. Then organic fertilizer behave differently depending on their manufacturing conditions and change the degree of soil permeability of different soil types, such as loamy, peaty, silty, chalky, or different soil types. Applying chemical fertilizers to the soil structurally altered by organic fertilizers without painstaking attention to the soil pest support can be noxious, because chemical fertilizers are already synthesized and include dangerous components for human health. And when you apply chemical fertilizers by altered soil by organic fertilizers, sometimes it can generate unexpected results and make the chemical fertilizer permeate the area more easily. Since chemical fertilizers can directly affect soil integrity and permeate through water bodies, contaminate the groundwater and the environment, it can create a health issue for humans and the wildlife. When chemical fertilizers disperse throughout water bodies, they increase micronutrients in the environment, such as nitrogen, potassium, phosphorus, resulting in contamination and eutrophication, and create an alg blasts or different spreading diseases in the area. How we can solve this problem? We can detect the excessive use of chemical fertilizers in the presence of organic fertilizers and provide real-time detection results. Because when you utilize organic fertilizer in conjunction with chemical fertilizers, they also change the appearance of the soil, its color, its integrity, even its surface. It changes them when it's altered by the organic fertilizers. After detecting these differences, pre-warn farmers to avert the detrimental effects of synthetic fertilizer overuse in relation to the applied organic fertilizers, collect data from a controlled environment manifesting different soil conditions. Since I talked about in the beginning of my presentation, to constrain and limit a problem, sometimes you need to create a controlled environment to create a solution. Since I cannot wander around different farms and different areas, I need to create a controlled environment to collect data. After that, again, inform the user of the detection results and create a case for this device operating outdoors. First, I need to capture fertilizer exerted soil images with SenseCap A1101. SenseCap product line is created by Seed Studio and have lots of different sensors and solutions for AI problems. In this device, it provides a AI camera which can run nearly 3 to 4 months without a battery change and can run models directly, collect data directly, and you do not need to worry about much because it's come pre-configured for also edge models. After assembling my plat 3D case, I produced organic fertilizer from coiled manure in different decomposition stages. As I explained earlier, I need to create a controlled environment and collect organic fertilizers to build my data set. Then as I feed quails on my balcony for egg production and have experience in converting quail manure in organic fertilizers, I utilized the quail manure I produced. Then I added chemical fertilizers, these collected quail manures, and set up the SenseCap A1101 on LaTePanda 3 Delta. You can easily set up LoRaWAN sensors provided by Seed Studio on following their tutorials. So just updating the firmware and it is ready to collect data by utilizing Python or different methods. Then I programmed SenseCap A1101 via LaTePanda to obtain comments transferred by Arduino via serial communication and capture pictures of fertilizer exerted soils. Unfortunately, Arduino SenseCap sensors does not come with a console to collect data with labels and create your own data set. So I decided to create a remote control, as I can explain in my following slide. To the created organic fertilizer in different composition stages, I collected fresh, active, and old 1 month, 3 months, 6 months, and added chemical fertilizer on each these flower pots: calcium nitrate, magnesium sulfate, ammonium sulfate, and ammonium phosphate to create my dataset. Then after programming, as I explained, I created a basic remote control with Arduino Nano, and it sends the selected class to the LaTePanda via serial communication. Then LaTePanda programs the Seed Studio to collect the information, capture the image, and add the selected class name to the collected image. I utilize 3 different classes: enrich, unsafe, and toxic. After utilizing 3 control buttons and collecting data nearly for 2 months, my flower pots, I constructed my dataset with notable validity. Then again, I built my object detection model with Edge Impulse, uploaded my samples, labeled target objects, created my model. But this time I utilize a different feature provided by Edge Impulse and added a metadata key to some samples of mine, because I decided to prevent leaking data between training and validation sets while training my model, because I realized enriched and unsafe samples can easily be misunderstood by the model. So I decided to exclude some of them and directly add them to validation samples to create a more accurate model. After evaluating the model, I deployed the trained model as a fully optimized SenseCap A1101 firmware. Since Seed Studio and Edge Impulse work together to provide solutions for their hardware and devices, Edge Impulse provides the option to create a pre-configured firmware when you trained your model on Olympus, and you can directly upload Senscape A101 sensor or other Senscape sensors. Then I decided to utilize, as I explained earlier, utilizing Twilio's API and directly send the detection results to the user via WhatsApp. I connected Senscape sensor vision AI sensor to the Senscape Mate app. You can follow my project tutorial to connect your Senscape sensors to the Senscape portal. I will not talk about that very much. If you have a Helium network provided near your area, you do not even need to purchase a LoRaWAN gateway. You can directly utilize the provided Helium network. After configuring the edge impulse model on Senscape Vision AI sensors, the Senscape Mate provides you the options to change the threshold, model threshold, and the uplink interval. It means how much you want to run the model in an hour. In this case, I decided to run 5 minutes. Every 5 minutes to run my model. After doing that, I utilized the Senscape Vision AI Sense module to transfer the detection results to the Senscape portal via the Helium Wi-Fi network. I already have Helium covering my surroundings, my area, so I do not need to purchase a LoRaWAN gateway. But in my tutorial, you can see I already explained how you can set up a LoRaWAN gateway if you do not have one covering your area. After again creating a Twilio account to utilize Twilio's WhatsApp API, I developed a basic Python application to obtain the model detection results from the Senscape portal by making HTTP GET requests to the Senscape HTTP API. Thankfully, Sitslio provides the Senscape API to obtain information from the Senscape portal, so you do not need to worry about creating a data collection system for your device while working with Senscape hardware, because it already provided an API and you can reach it utilizing different programming languages, such as, in this case, I utilized Python. Then I utilized the Python application to transfer the retrieved model detection result to the verified phone number and notify the user after running the model. Then by creating a device like this, we can prevent chemical fertilizers from contaminating the groundwater and the environment, avoid chemical fertilizers from dispersing throughout water bodies and increasing micronutrients in the environment, and mitigate the risk of severe health issues due to nitrate-contaminated water, because nitrate contamination and human intake can create DNA damage, lipid peroxidation, and oxidative stress. Also, protect wildlife from the execrable effects, detrimental effects of excessive chemical fertilizer use. Again, I added the project tutorial, so you can download all the 3D case files and model files to create your own device. And if you have any other further questions, you can inspect my other projects on my Hex profile and reach me on LinkedIn or Twitter. Thanks for listening and joining my presentation.
Thank you. Thank you so much. Thank you for sharing, Kutluhan. And we have some questions for you. So we can answer some questions now. There's a question from Victor. Can you programmatically upload data?
Sorry, can you repeat the question again? I did not hear.
Yeah. Can you programmatically upload data?
Yeah, I think it's about the yogurt texture project, I think. Yeah, I can programmatically upload data and change data even on the device for that project.
Okay. And is collecting or creating the word or data for analysis the largest or most important part of the project?
Yeah, I think creating the dataset is the most important part of the project, because the methods I explained are already provided by different brands, such as Seed Studio, Edge Impulse, you cannot create a solution without having the right information to work on.
Okay. And I want to learn tinyML, but I don't know how to extract the right information. And I have some projects related to IoT and how to start with it.
First of all, I highly suggest to inspect projects on Hextera or open source projects, AIoT projects. But it is not very hard after you extracting. Yeah, it can be hard, but I recommend utilizing Edge Impulse or other services for model training services before creating your own model with TensorFlow Lite or other devices, because Edge Impulse provides lots of different tutorials how you can take their data and implement it to your application and transfer it to the end user.
Okay. And we have another question from Peter. How do you make the leap from the bench scale to commercial scale?
First of all, I think about it. If I see this product, I will need it, or it is a better solution if I created this solution with utilizing only if-else conditions. Then if I think this project will help people more with ML and machine learning, I directly serve it as a commercial product. But in my projects, as all of my projects, I only create open source projects to improve it more and more with different people's additions on my projects.
And which sensor did you use for the pipeline diagnostics?
Pipeline diagnostics projects, I utilize MR60BHA1 60 GHz mmWave radar. You can find it on Seed Studio's website. And I utilize artificial vision to capture the deformed pipe images.
Yeah. And another question from Andrew. What method do you use to validate the models to ensure they are accurate?
First of all, I utilize, after training my model, I collected a different test data set, and I upload this test data set to Edge Impulse, and Edge Impulse provides a already built-in integrated method to validate your model based on this test data sets, real in-the-field data set. But if I do not like the results, and if the evaluation score, precision score below 60 or below 80, I always try and create new dataset, reevaluate my model again and again until I pass at least 75 of precision score on Edge Impulse.
And the last question, which stage are you filtering sensor data noise, and which tools are you using for such purpose?
For different projects, I utilize different applications. For example, by training my pipeline detect diagnostic systems, since I utilize the MMA radar module, I utilize some radar visualization methods, some LiDAR algorithms to detect if the data is correct or not. And I purchase three different radar modules in the same product line and test if one product is generating the correct data or there is a difference between them, and try to pinpoint the right solution. But mostly I do not need to tune my data because I already utilize sensors pre-configured by the manufacturer, especially Seed Studio and DFRobot provides you pre-configured solutions. They already test them and ship you after testing them correct, generating correct data.
Okay, good. Thank you. Thank you for answering the questions. And that's all we have for now. And for all the questions, we're gonna summarize them and post it to our website later. So thank you.
Thank you so much. Thank you for listening.
Okay, so in closing, I'd like to thank all the amazing partners again, and all of you who took part in this session today. And also a huge thanks to Kutluhan for sharing your knowledge and insights with us. And now I'd like to thank our executive strategic partners. First up, we've got Qualcomm, advancing AI research to make efficient AI ubiquitous. And then we got Sentient, accelerate your edge compute, making edge AI a reality. And we'll move on to Platinum strategic partners. Thank you to our Renaissance, which is enabling the next generation of AI-powered solutions that will revolutionize every industry sector. And Sony, deploy vision AI at the edge at scale. And we also have our gold strategic partners. So first we've got analog devices, where what if becomes what is. And we got Arduino, easily deploy your tinyML solutions with Arduino Pro. And we have ARM, build the future of tinyML on ARM. And we have Edge Impulse, the leading development platform for Edge ML. And we have Infineon, driving decarbonization and digitalization together. And we have Inatra, neuromorphic intelligence for the sensor edge. And we have Microsoft and SensiML. And we also have ST Microelectronics, who provides extensive solutions to make tiny machine learning easy. And we have Synaptics. We engineer exceptional experience for consumers in the home, at work, in the car, or on the go. And once again, I'd like to thank all the silver strategic partners, and a huge thanks to all the partners, participants, and attendees, and also Kutluhan Aktar. So let's continue this amazing journey together. Thank you.
Thanks.
That's all for today.
Thank you, everyone. Thanks.
Thank you.